So this is a geological map of the East Irish Sea, and it's one of the key areas that we use to study the potential of carbon sequestration on the UK continental platform. So here you have Anglesey, and if we follow the white line, we have the shoreline of northern Wales and eastern England, and we're actually looking at the rocks under the East Irish Sea. My name is David Gamboa. I'm a Sir Cymru Research Fellow in BGS, and I'm working on carbon capture and sequestration. We want to look at the potential to store and inject CO2, and from the information we can get from the seismic data, we can create models of the surfaces and also models of faults. We can, for example, estimate the leakage factor along a fault. So you're doing as well a risk analysis of the potential carbon sequestration reservoirs. And we can convert what will be just observed on a 2D map, and we can actually convert to a three-dimensional amount of data which can be mapped and modeled and get really detailed information about the geology and, importantly, outline the limits and volumes of potential reservoirs. We can compare this to an oil field, but instead of us extracting just a liquid from the depth, we're just actually injecting the CO2, which is injected in a supercritical state, so it behaves as a liquid, and we inject it in the subsurface and it spreads and stays there. We have to drastically reduce the emissions of our activity as a society, and carbon plays a very important role on the potential heating and climate change. So the key advantage of carbon sequestration is having the potential and the capacity to capture, to retrieve that carbon and store it underground in a safe place for hundreds, possibly thousands of years, and we're not sending it to the atmosphere. Quite often you wonder, why am I doing this and what's the relevance? But every day we come here, we're just trying to get solutions for some of the key problems in our society and how geologists can help solve them.